In this video, we're going to look at how to simplify surds. Surds are going to play a key part in some of your non-calculator tests, and you really need to know them quite well. So we'll kind of build up slowly. We'll look at the basics first, and then we'll look at some exam questions eventually. Okay. So remember the procedure. The skills ones, watch the video first, practice the questions, and then have a look at the exam questions when you're confident with all the basic skills. Okay, so we're going to look at how to simplify these surds, okay? So what I mean by that, so for example, if you had a fraction, 2 over 4, okay, we know that's equivalent to a half, okay? But if you had some fraction like 18 over 36, okay, that's also equivalent to a half, okay? And it's all about making life easier for yourself in terms of what you have to work with. It's easier to work with a half than it is 18 over 36 because the numbers are kind of like small, aren't they? You can sort of easily manipulate that half rather than working with 18 over 36. They're quite large numbers to work with, okay? So we're trying to get that same idea. We're trying to simplify this surd here, okay? Now, we're going to use one of the fundamental laws of surds, and that says if you have the square root of a number and you multiply this by the square root of another number, that's the same as the square root of both numbers multiplied together like this. So for example, if you had root 2 times root 5, that's the same as root 10, okay? But you can also go backwards. So for example, if you had root, let's say something like 15, okay, then that's equivalent to root 3 times root 5. Obviously multiplication works in any order, so you can have it written this way and it's the same, okay? So that's one of the basic laws of surds. If you multiply two surds together, you can combine them into one surd, okay? It doesn't quite work with addition, okay? So don't think it works with addition. Root 2 add root 5 does not equal root 7, okay? That's not true, okay? But for multiplication and division, actually, it's true. Okay, so we're going to use that basic law of surds to do the multiplication to simplify this, okay? And it's all to do with square numbers. Now, square numbers being 1, 4, 9, so 4 is 2 squared, 9 is 3 squared, and 16, which is 4 squared, 5 squared, which is 25, and so on. Okay, you need to know all your square numbers. I'd probably say up to and including probably 13 squared would be sufficient, which is 169. Okay, it's best to know your square numbers. Okay, the reason why square numbers are really useful in surds is because if you square root one of these, okay, you get a nice whole number. Okay, so for example, root 16 is 4. Root 25 is 5. Okay, however, root 26 is not going to be a nice integer answer. Okay, so only square numbers kind of square root to nice whole number integers. Okay, 26 doesn't. Okay, 14 doesn't. 7 doesn't, but something like 16 does. Okay, 81 square roots to a nice whole number. Okay, so we're going to use square numbers to answer this. Okay, and it's dead easy. Okay, we're going to use that fundamental law of surds, and we're going to look at what we're going to look at. We're going to look at how to simplify this surd now. Okay, what we need to do is look through the square numbers: 1, 4, 9, 16, 25. What is it? 36, 6 squared. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. I always forget 11 squared. What's 11? 121 is 11 squared. I always forget that one. And 12 squared is 144. And 13 squared is 169. Okay. What we've got to do is find the biggest square number that goes into this. Okay. Now this one's an easy one because it ends in 5, so it's got to be that, hasn't it, really? Okay. Can't be any other number, really, other than that square number. Okay. So what we need to do is think about how many times... actually, we always write the square number first because it's easier to do the next bit. So 25 times what gives us 325, okay? So that's 13. And if you don't know that, I mean, you could just kind of write your 25 times tables out. So 4 of them make 100. So we've got 3 lots of them. Okay, so there's 3 3 lots of that, sorry. So you can sort of like count, and then you'll see that's 13, okay? What was I going to do? I was going to, sorry, yeah, clear that. Okay, so let me get another one. All right, so we know that 325 is equal to 25 times 13, okay? And what we do is we put a square root around that because we're actually square rooting 325, which is this inside bit. And we're going to use that law of surd that I mentioned a moment ago, that if you have the square root of two multiples, that's the same as each individual number square rooted. Okay, so this 325 square root is equivalent to root 25 times root 13. I won't bother putting the time sign in the middle, but it is there. Okay. Now, the reason why we have root 25 is because that converts to an integer. So that becomes just the number 5. Okay, this here, let me convert that. Okay, this here is your simplified surd. That is the answer. Okay, 5 root 13. Now, 5 root 13 is equivalent to square root of 325, but it's much, much easier to work with 5 root 13 than it is to work with 325 square rooted. Okay, okay, let's try another one. Okay, this one's a bit tricky, isn't it? Right. Okay, so what was I going to say? Yeah. Oh, by the way, I never really say square root of 605 because it's too much to say that. I say root 605 or 605. So root just means square root. It's just easier to say that. Okay. All right. So this one's a bit tricky. Okay. It's not obvious straight away what square number goes into it. But what we'll do is we'll perform a little trick, and then maybe something will pop out. Okay. So what we need to do is basically, well, you could go through the square numbers one by one. 1, 4, what was it? 9. I always forget these. 9, 16, 25, and so on. Okay. In this case, it's probably not going to be 25, even though it ends in 5. It's probably not going to be that, because the 25 times table goes 25, 50, 75, and so on. So, or ends in 0. So it's not going to be that. Okay. You can go through the square numbers and try and figure out which one that goes in. But what I'm going to do is I'm going to just split this up. Okay. So 605, I'm going to divide it by 5. Okay, because I know it's going to go, I know 5 goes into it. There's got to be something to do with that number. And I'm just going to split it up. I'm going to divide it by 5. Okay, so 5 does go into 6, goes in once. Okay, remainder 1. 5 goes into 10 twice. Okay, remainder nothing, and 5 goes into that once. Okay, so actually we've got it now. So 605 is equivalent to 121 times 5. Okay, and I don't need to split it anymore because there's your square number right there. Okay, so the first stage is to write that as 121 times 5. So I always write the square number first. Okay, and then the square root of that is 11. So actually I skipped a bit, didn't I? So let me cross that out. So 121 times root 5. Okay, so remember, the square root of a multiplication, you can square root each number, and then that's 11 root 5. Okay, so there's your answer. We don't bother writing the time sign because it's just a bit too much work, and really it's not required. But there's your answer. Okay, now hopefully you'll get quite good at this, and you won't necessarily need to do this like the individual steps all the time. Okay, so you might be able to just go root. So this one's going to be 5 times, what's it going to be? 81. Okay, now you could write root 81 root 5, but the thing is though, I don't bother doing that because I know it's 81 square rooted, and that's just going to come out to be 9, and the 5 stays in the square root, and there's your answer. Okay, so you can skip bits, and when you get really good at these, you'll be able to just write the answer down. Okay, so oops, sorry, check the answer. Okay, that's fine. All right. Okay, so this one here, it's obvious to me that the only square number that goes into this is 4. So I know it's going to be a 2 root, and how many times does 4 go into that number? It goes in 6 times. So that's it. There we go. Okay, 2 root 6. So at some point, really, you'll get really good and you won't even bother writing down the two numbers that multiply it. Like this one, it's 9, isn't it? So it's 3 root 7. Okay, so you want to get to this stage where you're kind of doing them with ease. If you get stuck, always just break the number down into bits until you find that square number, or write all your square numbers out and then try and find the one that goes in. This is clearly 121 is 11 times 2, so it's 11 root 2. Okay, so keep going, practice a few until you're kind of getting it right each time, and then look at the next skill. Now just remember that one thing I did say, that rule only works for multiplication. It does not work for addition or take away. Okay, it does work for divide, by the way. So if you had root a over root b, that is the same as the square root of a divided by b. Okay, right. Okay, thank you for watching.